Welcome. Find a comfortable position and settle in. Let your body grow heavy, sinking into the surface beneath you. Breathe slowly, deeply. In through your nose, feeling the cool air, and out through your mouth, releasing the day. Tonight, we will drift through the quiet expanse of deep space, and in the stillness, let sleep find us. The universe can be a place of profound gentleness, of silent, slow dances that span eons. Yet, its most powerful, most violent moments are the very architects of everything we see, everything we are. But here, in this moment, you are perfectly safe. Let the journey begin. Our first destination is a star at the end of its long life. Imagine a giant, many times the mass of our own sun, having burned brightly for millions of years. For ages, it has been a stable beacon, a perfect balance between the outward push of nuclear fusion in its heart and the inward pull of its own immense gravity. But now, its fuel is nearly spent. The fusion furnace begins to sputter. Inside, the delicate balance falters. Gravity, patient and relentless, begins to win. The core, once a raging engine, can no longer support the weight of the star above it. It collapses in on itself in less than a second. This catastrophic collapse triggers a rebound, a shockwave that tears outward through the star's layers. A supernova blossoms, an outward rush of light and matter so brilliant it can outshine an entire galaxy of 100 billion stars. For a few weeks, it is the brightest object for light years around, a final glorious farewell. But this is not just an end, it is a creation. In the unimaginable heat and pressure of this blast, new elements are forged and scattered across space. The calcium in your bones, the iron in your blood, they were born in the heart of a dying star, in cataclysms just like this one. Sometimes, for the most massive of stars, the collapse does not stop. It goes further, crushing the core into an object of unimaginable density, a brand new black hole. As the star's outer layers rain down onto this newborn singularity, a cosmic engine ignites. Twin jets of particles, accelerated to nearly the speed of light, punch through the dying star from the inside out. This is a hypernova. A supernova on an even grander scale, sending a focused beam of gamma rays across the cosmos. A long gamma ray burst, or GRB, lasts only a few seconds, but it is the most luminous event in the known universe. If one of these beams were pointed at Earth, even from thousands of light years away, it would be catastrophic. But we are safe. We watch from a vast distance, seeing only the fading embers. The afterglow of the explosion, a gentle shimmer across the electromagnetic spectrum, can be seen for weeks, even months. We read this fading light like gentle ripples on a cosmic pond, learning the story of a star's final, powerful moments. Another kind of cosmic flash is shorter, born not from one star, but from the collision of two. Imagine two neutron stars. These are the incredibly dense remnants of past supernovas. The mass of our sun, squeezed into a sphere the size of a city. A single teaspoon of neutron star matter would weigh billions of tons. For millions of years, these two stellar ghosts have been locked in a gravitational dance, spiraling ever closer together. They kiss, then merge in a fraction of a second. The collision is so violent it rips apart the very fabric of the neutron stars, flinging a cloud of exotic neutron-rich material into space. This creates a kilonova, a flash of light 1,000 times brighter than a standard nova. In this churning radioactive cloud, the universe forges its most precious materials. The majority of all the gold and platinum in the cosmos is created in these brief, brilliant mergers. For us, on Earth, the event arrives as a brief whisper of gamma rays, and a tremor in spacetime itself, a gravitational wave, the signature of cosmic titans colliding. Even neutron stars that drift alone can have their own violent moments. Some are born with magnetic fields so powerful they defy imagination, quadrillions of times stronger than Earth's. We call them magnetars. This immense magnetic field puts the star's solid crust under incredible strain. Eventually, the crust cracks. A starquake, a seismic shift on the star's surface, causes the magnetic field to reconfigure itself in a violent snap. This unleashes a flare of energy that for a fraction of a second could outshine our entire Milky Way galaxy. A single brilliant heartbeat from a star far, far away. Now let us journey to the very centers of galaxies, where supermassive black holes reign. These behemoths, millions or even billions of times the mass of our sun, are not just passive voids. When they feed, they create some of the most sustained, powerful phenomena in the universe. Gas, dust, and even entire stars are pulled into a swirling, superheated disk of material around the black hole, known as an accretion disk. As this material spirals inward, friction heats it to millions of degrees, causing it to glow brighter than all the stars in its host galaxy combined. We see this as a quasar, or an active galactic nucleus, but not all the material falls in. Powerful magnetic fields can funnel a portion of this energy into two narrow jets of plasma, blasting away from the black hole at near light speed. These jets can travel for millions of light years, far beyond the visible confines of the galaxy itself. As they journey, they sculpt interstellar clouds, trigger or quench star formation, and inflate vast, invisible lobes of gas that glow brightly in radio waves. They are the galaxy's weather, writing their story on the canvas of the cosmos. Sometimes, a single unsuspecting star wanders too close to one of these sleeping giants. As it approaches, the black hole's immense gravity pulls more strongly on the near side of the star than the far side. This difference in force, the tidal force, begins to stretch the star. It is a process astronomers poetically call spaghettification. The star is unspooled into a long glowing stream of gas, a tidal disruption event. Half of the star's material is flung back out into space, while the other half is captured by the black hole, creating a brief, brilliant flare as it becomes a final luminous feast. Black holes do not only consume stars, they also meet each other. Across the universe, pairs of black holes born from massive stars or captured in galactic collisions orbit one another in a slow, inexorable dance. As they circle, they radiate energy away in the form of gravitational waves, ripples in the very fabric of space and time. This loss of energy causes their orbits to tighten, bringing them closer and closer, faster and faster, until they finally merge into a single larger black hole. In the final moments of the merger, an immense amount of energy is released, not as light, but as a powerful burst of these gravitational waves that wash across the cosmos. We don't see these waves with our eyes. They pass through us, through the Earth, completely unnoticed. But with incredibly careful and sensitive instruments, we can feel them, like listening for a deep bass note through the floor of the universe, a sound that tells us of a collision that happened millions of light years away. Let's drift closer to home now. Our own sun, by comparison to these cosmic behemoths, is a place of relative peace. But it too has its storms. Sometimes magnetic field lines on the sun's surface become tangled and snap, releasing bursts of energy as solar flares. Other times, it launches vast clouds of plasma into space, called coronal mass ejections. When these storms wash over our planet, they rattle our protective magnetosphere, but they also give us a gift. The aurora. Charged particles from the sun are guided by Earth's magnetic field to the poles, where they excite atoms in our atmosphere, painting the night sky with shimmering curtains of light, a gentle reminder that even small storms can be breathtakingly beautiful. Across all of this apparent violence, a deeper pattern emerges. Creation follows destruction. The shock waves from supernovas and the jets from black holes do not just destroy, they compress vast, cold clouds of interstellar gas and dust. This compression triggers gravitational collapse, giving birth to hundreds or thousands of new stars at once. The most violent events become the nurseries for the next generation, and around these new stars, planets condense from the leftover material. Our own solar system was formed from such a cloud, enriched with the heavy elements forged in the fire of ancient supernovas and kilonovas. The very ground beneath our feet, the air we breathe, the substance of our bodies, all are made of stardust, gathered and recycled over billions of years. Life itself gathers these elements, forged in cosmic fire, and weaves them into consciousness. Take a slow, deep breath now. Let your breath match the slow, graceful orbits of the cosmos. Inhale as the galaxy turns its ancient wheel. Exhale as the light from a distant, long-dead star finally reaches your eye. There is a rhythm to the universe, a slow and steady pulse beneath the chaos. Feel it now, in the rise and fall of your own chest. The loudest, most energetic events in the universe are, from our quiet vantage point, distant and softly glowing. Their fury is transformed by distance into something gentle, something beautiful, a whisper of light, a tremor in space. They are part of a grand cosmic story that unfolds on scales of time and space we can barely comprehend. And you are here, a part of it all. You are safe, small, and perfectly placed to rest. There is nothing you need to do. Nowhere you need to be. Simply, allow yourself to be held by the stillness. Close your eyes, if you haven't already. The night is wide and deep, and the cosmos keeps its silent, steady watch. Let go of your thoughts. Let them drift away, like distant galaxies. Sleep well.